Welcome back to the deep dive. This is where we dig into the technical reports, the market analysis, all that dense corporate history, and we really distill it down into the knowledge you need.
And today, we are talking about a company that is just synonymous with heavy-duty power.
Oh yeah, we are strapping ourselves into the cab of Cummins Inc., a company you hear and well, you immediately think of big rigs, of that iconic diesel rumble.
Right, but that iconic sound, that's both their legacy and the source of, this immense pressure they're under today.
Yeah, the sources we went through, they really paint a picture of a fascinating paradox, don't they?
They do. Cummins absolutely mastered the internal combustion engine. They turned it into a $34 billion global powerhouse.
But that same dominance came with just a massive financial cost. I was looking at the numbers. It's nearly $2 billion in U.S. regulatory fines in just the last 25 years.
$2 billion. And that's the story right there.
Okay, so let's unpack that. Our mission today isn't just a history lesson. It's really an exploration of corporate survival and, frankly, a radical pivot. We need to understand how a company that was founded way back in 1919 in Columbus, Indiana.
Right, on an engine technology that was already 2 decades old at that point.
Exactly. How did they manage to dominate transportation and power generation? But even more importantly, why is this champion of diesel now in this aggressive, high-stakes race to master zero-emissions power with their new unit, Accelera?
That pivot you mentioned, that's the whole story for modern Cummins. They're not just, tweaking things to follow market trends.
No.
They are trying to pull off an industrial-scale transformation, all while living under the shadow of these huge regulatory penalties.
And the scale is just as hard to get your head around. It started with 2 people.
Just 2. The mechanic, Clessie Lyle Cummins, and his financial backer, the banker, William Glanton Irwin.
And today, they're operating in what, nearly 190 countries and territories?
A massive player. We're talking U.S. $34.1 billion in revenue for 2024, with almost 70,000 employees globally.
And the product line is, it's everything now. It's the whole energy spectrum. You've got your traditional diesel and natural gas engines, sure, but also filtration, advanced turbocharger.
And then the future-facing stuff, hydrogen fuel cells, industrial batteries, all those complex components. It's a full-spectrum power company.
Okay, so this is the deep dive, the race against their own legacy.
Let's start at the beginning.
Let's do it. Part 1, the persistence of diesel, their early history, and how they built that dominance.
Well, the foundational partnership back in 1919, it's a classic story, really. You have Clessie Cummins, the absolute mechanical genius.
The tinkerer.
Completely consumed with making the diesel engine reliable, economical, and, small enough for transportation.
And then you have the money. William Glanton Irwin, the banker who had the patience and, crucially, the deep pockets to fund what turned out to be a really long R&D cycle.
Irwin's role is key. I mean, like you said, Cummins wasn't inventing diesel. Rudolf Diesel's patent was 20 years old.
They were just trying to tame it. Take this brilliant but temperamental, expensive technology and turn it into a real product that could compete with the gasoline engines of the time.
And it takes relentless funding. And, because the tech was known but had basically failed to find a market, their initial success was anything but guaranteed.
Right.
The sources show a nearly 15-year struggle. Clessie understood that skepticism was his biggest enemy. People trusted simple gas engines. Diesel was complicated, unproven.
So how do you convince the market? This is where he shifted from being an engineer to something of a showman, right?
Absolutely. Clessie became a master of what the sources call well-publicized endurance trials.
These weren't just lab tests.
Oh, no. He deliberately sought out these grueling high-visibility challenges. Imagine it's the 1920s. He's putting a Cummins engine in a race car at the Indianapolis 500.
Multiple times.
Yeah, or driving coast to coast. Just trying to prove diesel was more fuel efficient, more reliable than anything else out there. It was extreme public proof of concept.
It's a genius marketing strategy for a technical product. Make it exciting. But even those spectacles didn't lead to huge sales right away. Where was the real commercial breakthrough?
It didn't come until 1933. And this is the surprising part. The first confirmed commercially successful product was the Model H engine.
Okay.
And its application wasn't in a big truck on a highway. It was in small railroad switchers.
The little yard engines,
Yeah.
why there?
Because a railroad yard is a brutal environment for an engine. They're under constant extreme load. All day long it's start, stop, high torque, moving incredible weights at low speeds.
It's the ultimate stress test.
Exactly. The reliability and torque of the Model H proved it was superior in that one punishing niche. And once they conquered the railroad yard, the rest of the market finally accepted that this Cummins diesel was ready for the heavy-duty road.
That credibility, forged in the middle of the Great Depression no less, it positioned them perfectly for what was coming next.
The post-war boom, the 1950s, all that massive infrastructure spending, the creation of the interstate highway system, that was their golden age.
And the Cummins N-Series engines became the industry standard.
They were in everything: construction equipment, long-haul trucking. The sources quantify it perfectly. From 1952 to 1959, just a 7-year stretch.
What was it?
Cummins engines were in more than half of the entire heavy-duty truck market.
More than half. That's not a market position, that's market control.
And they were already thinking globally. While a lot of American companies were just focused on the domestic boom, Cummins opened an assembly plant in Shot, Scotland in the 1960s.
That plant eventually closed, but it showed their intent early on.
It did, and by 2013, they had operations in 197 countries. So that global mindset was part of their DNA from the very beginning.
Okay, so that's the foundation. Persistence, smart marketing, and conquering the post-war road. But to understand the $34 billion operation today, we have to look past the engine block.
You have to look at the modern company.
Let's move to part 2, the 5 business pillars of Cummins.
This is critical, because if you think of Cummins as just an engine company, you're missing the whole picture. It's like calling a skyscraper just a foundation.
It's a full-stack power ecosystem.
Exactly. And if you understand these 5 units, you understand how they make money and how they manage risk in this rapidly changing landscape.
So pillar 1 has to be the core, the engine business itself.
Section 2.1, the Cummins engine business. This is the historical heartbeat, the source of that famous rumble.
And it covers pretty much every application you can imagine. Heavy-duty trucks, buses, RVs, and all those industrial sectors.
Mining, rail, marine, defense, you name it. But for a lot of our listeners, their most direct exposure to a Cummins engine is through one very specific, very legendary partnership.
The Dodge Ram.
The Dodge Ram heavy-duty pickups. Starting in 1988, they put the 5.9-liter i6 engine into those trucks. And that move just fundamentally redefined the heavy-duty pickup market.
It created this fiercely loyal following of owners who wanted that durability, that immense torque from a diesel. It gave Cummins a consumer visibility they'd never had before.
And that engine has had incredible staying power. It evolved into the larger 6.7-liter version that's been in the Ram since 2007. It's famous for its longevity.
But even that iconic engine ran into some pretty massive manufacturing challenges.
Right. We talked about complexity being a risk, and the 53 block controversy is a perfect example. A class action suit was filed back in 2008.
And this was about the Cummins ISB 5.9-liter diesel in Dodge Rams from about 1998 to 2001.
That's right. The allegation was that a specific casting pattern on the engine block, marked with the number 53, was structurally weak.
Prone to cracking.
Prone to cracking, which would create a coolant leak. And if you don't catch that, it could lead to catastrophic engine failure.
So how did that end?
The case was settled, and qualified owners got a $500 settlement for repairs. But it just shows you how a tiny technical detail in manufacturing can cascade into this huge legal and financial problem involving hundreds of thousands of vehicles.
The challenge of high-volume manufacturing. But before we leave the core engine business, it's worth noting they didn't just stick to diesel, even within internal combustion.
No, they've been proactive. Back in 2013, they partnered with a company called Westport Innovations to ship large natural gas engines to U.S. truck makers.
So it wasn't a new engine design, really, but a new fuel strategy.
Exactly. It coincided with the expansion of the natural gas distribution network. It shows they're always thinking about how power generation has to match the available infrastructure.
And their R&D is global, too. There's a big technical center in Darlington, England.
Yeah, that one's focused specifically on products for the European, Middle Eastern, and Asian markets. They don't just build one engine and push it everywhere.
Right, they have to customize for all the different emission standards.
Which vary wildly. And we should also just briefly mention the really specialized stuff here, like the military-specific V903.
A 14.8-liter V8.
Yeah, which powers things like the Bradley fighting vehicles. It's just a good reminder that their engine business goes way deeper than just highway trucks.
Okay, so that's the core. What about pillar 2, the components business?
Section 2.2. If the engine is the muscular core, the components business is the brain and the lungs. It provides all the hardware and software to make sure that core runs efficiently and compliantly.
This is all the support systems.
All of it. There are 5 key areas: emission solutions, filtration under the Fleetguard brand, fuel systems, turbo technologies, and electronics.
Let's focus on a couple of those. The Tobos first.
That's the Turbo Technologies unit. It operates under that very famous brand name, Holset.
Right.
They specialize in turbochargers, but specifically for diesel engines above 3 liters. These aren't just aftermarket add-ons. They're incredibly complex precision devices you need to meet power and efficiency targets.
And the second critical part, the digital brain.
The electronics unit. This is where the real intelligence is. They design the engine control units, the ECUs, and all the sensors.
And the ECU manages everything.
Everything. Fuel injection, airflow, and most importantly, the complex algorithms that govern emissions control. And as we'll get into later, that ECU software is both the source of their modern performance and the source of their biggest regulatory risk.
And Fleetguard just keeps everything clean.
A vital job. Air, fuel, hydraulic, lube filtration. In mining or construction, those engines are in the absolute worst environments. If you don't keep the fluids and air clean, the engine just dies. Simple as that.
Okay, on to Pillar 3, Cummins Power Systems. This is their off-grid power business.
Section 2.3, yeah. This traces its lineage back to the Cummins Onan Corporation. It's the segment that provides power when the road ends or the grid goes down.
Backup power specialists.
Right, and their product line is huge. Everything from small consumer generators to huge commercial power systems, alternators, automatic transfer switches.
It's interesting they're also into paralleling systems, which let multiple generators work together.
That's the move toward high-capacity stationary power. And speaking of shifts, it's really important to note that in August 2017, they sold off all their mobile power generation assets.
All of them. To who?
To United Rentals.
Why would they sell off a business that seems so core to their history?
It was a strategic move, a streamlining effort. By selling the mobile assets, which require a huge service and rental infrastructure, they let a specialist like United Rentals handle that, while Cummins could focus its own resources on the stationary, high-horsepower industrial systems.
Optimizing for higher margin complex systems makes sense.
Exactly.
Pillar 4, the distribution business. This sounds administrative, but you can argue it's the most important part for keeping customers happy.
Section 2.4. You're right. If a mining truck breaks down in the middle of nowhere in Chile, or a generator fails at a hospital in India, this is the unit that saves the day.
It's the global service and parts network.
It's their global nervous system. They have 17 company-owned distributors, 10 joint ventures, covering 90 countries with 234 locations.
That's a massive footprint.
It has to be. When you're dealing with mission-critical assets, defense vehicles, marine vessels, oil rigs, uptime is everything. This network ensures that a Cummins part or an expert technician is never too far away. That's a huge competitive advantage.
Okay, that brings us to the fifth and final pillar, the most forward-looking, high-stakes division of them all, Accelera.
Section 2.5, Accelera by Cummins. This is their explicit answer to the climate and regulatory challenges of the 21st century.
This is their future.
This is the future of Cummins. It was rebranded from the New Power unit in March 2023. And this isn't some cautious little side project.
Yeah.
This is a comprehensive, dedicated focus on zero emissions power. They're basically trying to replicate their success in diesel across 3 or 4 new energy platforms all at once.
And what makes their approach so aggressive?
They're betting on the whole spectrum. Accelera makes hydrogen fuel cells, which are great for long-haul trucks where battery weight is a problem. They also make batteries, e-axles, and traction systems for EVs.
But the crucial piece, the real foundational commitment, is the electrolyzers.
That's the key. Electrolyzers are the machines you use to produce clean hydrogen fuel from water. So they aren't just selling the components for the vehicles, they're investing in the infrastructure required to actually generate the fuel for the new hydrogen economy.
It shows they understand the whole supply chain problem, just like Plessy Cummins had to solve the diesel reliability problem 100 years ago.
And this unit, Accelera, is the financial counterweight to the massive regulatory risks we're going to talk about in Part 5.
That sets the stage perfectly, because even as they're racing into the future with Accelera, they are still consolidating their traditional power. Let's get into that in Part 3. Specialization, subsidiaries, and their global footprint.
Right. When you look at their acquisitions, you see this relentless focus on securing strategic IP and manufacturing so they control every critical component of their engines.
Let's start with Holset, the turbocharger brand.
Holset Engineering was originally a British company. Cummins saw how important it was to control forced induction technology, so they bought them way back in 1973.
And they kept the brand name.
They did. They renamed the division Cummins Turbo Technologies in 2006, but they wisely kept the Holset brand for the turbos themselves. That name recognition is priceless in the heavy-duty world.
And their manufacturing for Holset is global, just like the rest of the company.
Centralized IP, but decentralized manufacturing. China, India, Brazil, the UK. But maybe the most fascinating story of reacquisition involves the engine brake.
The famous Jake brake.
Exactly. Plessy Cummins himself invented the engine brake in the late 1950s. But he sold the technology to Jacobs Chuck in 1961.
And Jacobs created a whole division to make it.
Yep, Jacobs Vehicle Systems. And then, in 2022, Cummins bought that very same company.
So they bought back their founder's invention. That's an incredible full-circle moment for IP strategy.
It's a huge move. They still use the Jacobs name for the brake products, but that division now designs much more advanced tech, specifically variable valve actuation systems.
Okay, let's quickly define VVA for the listener.
VVA, variable valve actuation. It's critical for modern engines. It's technology that lets the engine precisely control when the intake and exhaust valves open and close.
Which you need for what?
For optimizing power, for engine braking, and most importantly, for enabling the complex emissions control strategies required to meet today's strict standards. By owning the VVA tech, Cummins controls the heart of a modern, compliant diesel engine.
And quickly, the Onan rebranding shows a desire for a single, unified brand.
Yeah, they bought Onan back in '92. In 2017, they decided to consolidate. They retired names like Cummins Power Generation. The Onan name was repositioned just as a product line, the mobile generators for the RV market, all under the single Cummins brand.
It's about making the promise of Cummins dependability consistent everywhere.
Precisely.
Now, this huge investment in Accelera and green power, it hasn't gone unnoticed politically.
Not at all. The visit by President Joe Biden to the Cummins plant in Fridley, Minnesota in April 2023 was a very strong signal.
And that visit was part of his Investing in America tour. What was the focus?
It was centered on Cummins announcing a massive $1 billion initiative to accelerate clean energy tech production. The Fridley facility was highlighted specifically for producing those electrolyzers for hydrogen cells.
So the government is seeing Cummins, a traditional diesel giant, as a key domestic partner in the whole transition to a hydrogen infrastructure.
Exactly. It's proof that the Accelera investment isn't some marginal side project. It's a serious capital-intensive move to secure U.S. manufacturing leadership in the clean energy space.
Okay, let's talk about their global hubs, specifically China and India, because China is where the sheer volume of their engine business is, and that has huge strategic implications.
China is fundamental to their current success and their future engine design. They have several successful joint ventures, but the most significant is the Beijing Foton Cummins engine company.
And that Foton joint venture is responsible for the engine platform that is now the backbone of their entire global line.
The ISGX-12 engine platform, that's the core insight here. It was developed by that joint venture in the mid-2010s, and it's a masterpiece of high-volume engineering.
What kind of volume are we talking?
The sources say production in China has surpassed an astonishing 240,000 units per year. It is now the single highest volume heavy-duty engine in the entire global Cummins lineup.
240,000. And here's the crucial sentence from the sources. The ISGX-12 platform is the foundation for all future Cummins engine platforms.
Let that sink in. It means no matter where a new Cummins engine is designed, the architecture, the design lessons, the manufacturing cost efficiencies, they all come from their Chinese joint venture. The center of gravity for their highest volume tech is in China. That's a major strategic reality.
And you contrast that high-volume manufacturing with their presence in India, which also has huge scale but focuses much more on R&D and technical talent.
Cummins India is a massive operation. By 2013, it was already doing $1.5 billion in revenue with 20 factories. But the investment in human capital is what really stands out.
The technical center in Pune.
Yes. They established the Cummins Research and Technology Center in 2003, and that Pune Center, CTCI, now houses over 2,500 engineers. This isn't a back office, it's a major globally integrated R&D hub.
And as a sign of their long-term commitment there's that detail about the Women's Engineering College.
It's remarkable, the MKSSS Cummins College of Engineering for Women in Pune. Establishing a dedicated women-only engineering college shows this deep institutional investment in fostering local talent, ensuring they have an R&D pipeline for decades.
It's a very sophisticated global strategy, then. Control the core IP, like Holset and Jacobs, secure the future fuel tech with Accelera, and leverage the manufacturing scale of China and the R&D talent of India.
That's the playbook.
Okay, let's quickly run through the engine catalog in Part 4, not as a list, but to see how they've strategically covered every single market segment.
From light-duty delivery trucks all the way to mountain-moving mining equipment.
Let's start with the IS, or Interact series. This is their on-highway power. The trucks, buses, RVs.
And the strategic insight here is how deeply integrated this IS family is across the whole industry. Take the ISB 6.7-liter i6, the one in the Ram trucks and school buses. It's such a proven design that other major manufacturers just buy it and rebrand it.
Like who?
The sources confirm it's sold to PACCAR and branded as the PX6 or PX7, and to Scania, where it's called the DC07.
So the heart of trucks made by their competitors often has a Cummins design inside. That's the ultimate measure of market dominance.
It really is. And they offer alternative fuels in this family, too, with the ISLG and ISXG natural gas engines.
Right. So now, if the IS family is the road, the QS or Quantum series is everything off-road.
Section 4.2. Exactly.
Right.
Rail, marine, construction, mining, extreme power generation. This is where you see the immense scale of their engineering.
These engines are designed to literally move mountains.
They go way beyond the 15-liter limit of highway trucks. We're talking about the QST 30-liter V12, the QSK 78-liter V18, but the true definition of extreme power
is their largest offering, which is
the QSK 95-liter V16. To give you some perspective, this engine is taller than an average person and weighs more than several cars.
And it's used in what?
Ultra-class mining haul trucks that carry hundreds of tons of rock. It just proves that Cummins engineering can deliver power at the absolute apex of industrial demand.
And looking forward, the evolution of the on-highway IS family is the X series.
Correct, the X12 and the X15. These represent the latest optimization of their heavy-duty architecture, building on that foundation we identified in China. Cleaner, more efficient, squeezing every last drop of performance out of diesel tech.
And the final symbolic piece of the pivot, the concept vehicles.
The Cummins EOS, an all-electric conventional truck concept. The EOS is crucial because it shows they can transfer all their knowledge of integration, cooling, durability from diesel into the electric world.
It's a message to the market.
Exactly. The brand is telegraphing that even when the power source changes, the promise of heavy-duty reliability remains.
Okay. We've built the whole picture, the history, the 5 pillars, the global footprint. But this entire narrative is being driven by the enormous financial pressures we hinted at.
It is.
So, Part 5. Let's address the critical risk driving this whole zero emissions pivot, the high cost of emissions and regulatory failure.
This section reveals the vulnerability of the entire $34 billion structure. Compliance is incredibly complex, and failure, especially repeated failure, is ruinous.
We have to start back in 1998, a landmark moment that really shook the entire diesel industry.
It did. The EPA leveled fines of $83.4 million against Cummins and 6 other diesel manufacturers. At the time, that was the biggest fine ever.
But the way they cheated is what's so shocking. They basically had a cheat code built into the engine's digital brain.
That's the simplest way to put it, the defeat device. The EPA found that manufacturers were using sophisticated ECU software that was programmed to recognize the exact parameters of the 20-minute lab test for Clean Air Act compliance.
So during that test, the pollution controls would engage fully,
making the engine look perfectly clean. It passed the test every time.
But what happened the moment that truck left the lab and started driving on a normal highway?
The software quietly, deliberately disabled the full emissions controls. The result was trucks emitting NOx, nitrogen oxides, at up to 3 times the legal limit.
And NOx is a serious pollutant.
A major contributor to smog and respiratory problems. The fallout was immense. The manufacturers were mandated to spend more than $1 billion to fix the problem.
Over $1 billion, a quarter century ago. You would think a lesson that expensive would lead to permanent changes.
You would think.
But then we have to address the record-setting fine that hit them just recently.
The 2023 fine redefined massive. In December 2023, the U.S. Justice Department fined Cummins a record-setting $1.675 billion.
$1.675 billion.
It just dwarfs the 1998 case, and the scope of the deception was incredibly broad, spanning a full decade of production.
From model years 2013 to 2023.
Right. Cummins was found to have installed defeat devices to bypass or disable emissions controls on an astounding 960,000 Vicinal Birch, Dodge, and Stellantis Ram pickup diesel engines.
Nearly 1 million vehicles. The core consumer vehicle we talked about. This wasn't a mistake. It suggests a systemic institutional practice that went on for years. What was the total financial hit?
On top of the record fine, the company agreed to pay another $325 million in remedies and recalls. That included recalling and fixing 600,000 diesel Ram trucks.
So the total cost is approaching $2 billion. That sends an unmistakable signal, doesn't it?
It says that the regulatory risk of staying in the complex, high-emissions technology game has become financially toxic.
These two major cases, separated by 25 years but connected by the same type of defeat device, they aren't just news stories. They are the single strongest financial argument for why the Accelera business unit has to exist.
Absolutely. When the risk of diesel compliance reaches $2 billion, the transition to zero emissions tech, which inherently lacks those complex pollution control systems, it stops being a philosophical choice.
It becomes a critical financial imperative for survival. It's about mitigating future regulatory risk.
And that ties everything together. The global scale, the specialization, the technical expertise, and these regulatory challenges all point to one overarching corporate strategy.
They have to transition to survive.
Exactly.
Okay, so to recap. We dove deep into Cummins Inc., tracing their story from Plessy Cummins' persistent push to commercialize a diesel engine back in 1919, all the way to becoming this global power infrastructure giant.
They dominate heavy transport, military power, stationary power, all through strategic IP control and the sophisticated global footprint that leverages both Indian R&D and Chinese manufacturing scale.
We've seen, though, that technical dominance comes at a shattering cost. The massive, repeated Clean Air Act violations, culminating in that record 2023 fine, expose the systemic financial risks tied to complex emissions compliance.
And that risk has catalyzed this rapid multi-billion-dollar shift into Accelera, positioning Cummins to lead in hydrogen, in batteries, and even in the production of green hydrogen fuel itself.
So the company is now effectively split. One foot is still firmly planted on that diesel foundation built over a century, and the other is sprinting toward a zero-emissions future. But here is the final provocative thought for you to consider as you reflect on all this. We established that the massive high-volume success of the ISGX-12 engine platform in China is the technical foundation for all future Cummins engine platforms. Given that foundation is still diesel-based, and given the existential financial penalties they've incurred in the West, how much intense institutional pressure is now on the Accelera unit to succeed, not just as another profitable venture, but as the only long-term pathway to mitigate that regulatory risk and completely replace the $2 billion legacy of diesel dominance?